All right, everybody pull up 5.4, sum and difference. Sum and difference. Guys, what does the word sum mean? When you add two things together, what is difference? When you subtract, okay? You guys will be given these formulas. If you were in the other pre-calc classes, you would not have these formulas. You have to memorize them. So be thankful that you guys will be given these formulas. But what we're going to do is we're going to find stuff on the unit circle, and then we're going to do it with triangles here in a second. But we're just going to figure out what two things will add up or subtract to give us what we're looking for, is basically what we're doing, okay? Do you notice that for each trig function, there's two formulas? Can we see that? For sine, there's two, whether it's either adding or subtracting the angles. For cosine, there's two. It's either adding or subtracting. And for tangent, there's two. Either adding or subtracting. Everybody with me? Okay, now silly mistakes. You guys have these formulas. You'll have them in front of you. No big deal. But silly mistakes you'll make. Look at the sine formula. It says if you're adding u and v together, then the formula has a plus sign in the middle. Makes sense, right? With the subtraction, if you're subtracting the two angles, there's the minus sign in the middle. That makes sense. If you are looking at the cosine formula, if you happen to be adding the two angles together to find the cosine, in the formula, what sign is it? Subtraction. Okay, it's the opposite. You guys will have these formulas in front of you. So if you're not paying attention, you're going to make a silly mistake that will make a really big error. That'll mess up your answer, everything. So just pay attention to what you're doing. All right, there's three different types of problems that we're going to do. So let's do these first ones together. It says find the exact value of cosine 75 and sine of pi over 12. Now, guys, exact value means no decimals, right? So you have square roots or something like that. If I asked you for the exact value of a cosine, and it's on the unit circle, you would just tell me whatever the x coordinate was, right? If I said, what is the sine value of 7 pi over 6? You'd say, okay, well, it's the y. These examples are not on the unit circle. So what you are going to do is you're going to identify the formula you're going to use, whether it's sine, cosine, or tangent, and then you guys are going to choose the angles you want to use. Not every single way, there's not just one way to do this, what I'm saying. If you have to find the exact value of cosine 75, okay? Cosine, that means I'm going to use one of these formulas. Right here, correct? Because it's cosine. I have to look on my unit circle and see what two values I could either add or subtract to give me 75. What are some options that I could use? What 2 degree measurements could add or subtract to give me 75? Tell me.
45.
Okay, 30 plus 45. You guys agree? Okay, that's fine. Anything else? No other combination that I could get 75?
Is it only adding or subtracting?
No, add or subtract.
135 and 60.
135 and 60. What's 135 minus 60? All right, so Mikey said 135 and 60. Yeah, that would work. Anything else? 225 and 150. Okay. Do you guys understand what we're doing, how to find combinations? There is not just one specific combination. You can add 2 to get the number you're looking for. You can subtract the 2 to get the number you're looking for. Whatever you choose to do is fine as long as it equals the number that we're looking for. I'm going to go with 45 and 30 because they're both in the first quadrant. It's good to go. If you want to do it with what I have circled in yellow or what I have circled in red, that's perfectly fine. You just have to choose the right formula. What am I doing with 45 and 30 to get 75? Adding, okay? So I'm going to say, I'm going to use the cosine formula because I'm trying to find the cosine of 75 degrees. So I'm using the cosine formula where I'm adding 30 plus 45. You guys agree with me? Yes or no? Okay. Well, what is the ordered pair at 30 degrees? Pi over 6. Okay, what's the ordered pair? What is it? Square root of 3 over 2 and 1/2. Okay. What is the ordered pair at 45 degrees? Look at your unit circle. Square root of 2 over 2. Square root of 2 over 2. Yeah? Okay, so far the only math we've had to do is add two numbers together or subtract, depending upon what you guys chose. Now, given these two ordered pairs that are on the unit circle, you don't have to do this. I just think it's a good idea. I go ahead and label that my x value is the cosine and my y value is the sine. You guys agree with me on that? Yes or no? Okay. Now you have every bit of information you need in order to find the exact value of cosine 75. The letters that they use in the formulas are u and v. So I'm just going to use the same ones. I'm going to say that 30 is my u, 45 is my v. Now, you guys told me that we're using this formula right here, right? Because we're adding the two angles together. So it's cosine. You don't even have to write it down because you guys are looking at it. What is the cosine of what we deemed u? What's cosine? Root 3 over 2. All right, then the formula says cosine of v, which is square root of 2 over 2. All right, then what sign's in the middle? Minus, good. Then I have sine of u. What's the sine of u? 1/2 times the sine of v, which is root 2 over 2. And now, we simplify. What's the square root of something times the square root of something? Just a bigger what? Square root. So square root of 3 times square root of 2 is the square root of 6. And I multiply the bottom. 2 times 2 is 4. Minus, what's 1 times the square root of 2? Square root of 2. What's 2 times 2? 4. Can I simplify this a little more? Do they have the same denominator?
Yeah.
Yes. So can I rewrite this over the same denominator? Yep. Square root of 6 minus the square root of 2. Can you subtract the square root of 6 minus the square root of 2? No. That is not 6 minus 2. If it was, then yes. But square root of 6 minus the square root of 2, you cannot combine. That is your exact answer. That's it. Now, if you used a different combination of numbers, and then you use the other cosine formula, you might have come out where it was negative root 2 plus the square root of 6. That's okay. It's the same thing. As long as the two angles that you find add or subtract to give you the number that you're looking for, it doesn't matter if we all use the same one or not. It just has to be mathematically correct. Does that make sense? Okay. All right. Let's look at the second one. Letter B. Letter B says the sine of pi over 12. Now, pi over 12 is not on the unit circle. So how in the world are we going to figure out the two angles that we need to use if we don't even know where pi over 12 is on the unit circle? What can we do? Well, but pi over 12 isn't on the unit circle, so how could we figure out? Tell me. Yeah, go ahead and change it to degrees. Oops. How would I convert this? Pi goes on the bottom, 180 on the top, right? So my pi's will cancel. What number goes into both 12 and 180? 6, okay. 6 goes into 12 twice. 6 goes into 180, 30. Can I simplify more? Yep, what's 30 divided by 2? 15. So what I'm really trying to find, guys, is the sine of 15 degrees. So I know right now which trig function I'm looking for, which is what? Sine, right? Top two. So I'm going to go to my unit circle, and I'm going to find two angles that when I add them or subtract them, I get 15. What could I use? Okay. I could use 45 minus 30, right? What else could I use?
Can't you basically use like all?
You can use anything. Anything you want. I'm going to use 240 and 225. If I were you, I would always try to use something in the first quadrant because the signs are positive, but it doesn't matter. I just want to show you. You guys can use anything. Mikey said, Kate, you basically use anything? Yeah. You could do 135 and 120. You could do 60 and 45. You could do 330 and 315, right? Anything that when you add or subtract, you're going to get 15 degrees. So I'm going to use 240 and 225. So I already know it's my sine, right? Well, what am I doing to 240 and to 225 to get 15? So it'd be 240 minus 225, right? You guys agree? Okay. What is the ordered pair for 240? Thank you. -1/2 and -√3/2. And then what is my ordered pair for 225? -√2/2 and -√2/2. Perfect. Now, what I like to do, just so I don't make any silly mistakes, is over the x value, I like to write cosine. Over the y value, I like to write sine. And now I have all the information I need to plug into my formula. I'm using the sine formula that subtracts the two angles. So look at your function, look at your formulas. Sine that subtracts. It's sine of u times cosine of v. So the sine of angle u is what? -√3/2 times the cosine, right, of v, which is -√2/2. Minus, it's the second part, cosine u sine v. So what's the cosine of u? -1/2 times the sine of v, so it's -√2/2. What's -√3 times -√2? Positive square root of 6 over what number? 4. Minus, what's -1 times -√2? Right, square root of 2 over, what's 2 times 2? 4. How can I simplify this? Square root of 6 minus the square root of 2 over 4. That's it. Are those two answers the same? Yes. Is that just by happen chance? Yes, not a big deal. Lots of times, guys, you'll get some very similar answers because remember, the unit circle is a what? It's a pattern. You're going to start to see the same things over and over again. If you chose different combinations, you might have gotten -√2 plus the square root of 6 over 4. That's the same thing. It's fine. You just have to figure out what two numbers on the unit circle will add or subtract to what you're trying to find. Does that make sense? Now, this is a lot harder, I understand, if you don't have the unit circle and if you don't have the formulas. But you guys have both of those. This is pretty straightforward. Questions? Let's go to the next one. I want to do example 3 first, and then I'll go up to example 2. All right, example 3. For some reason, this gives people some trouble, and honestly, I don't understand why. This says, write as a single trig function and evaluate. What you guys are doing in a case like this, you're working backwards. All right, again, you have access to the formulas. So you're looking. The first thing you're going to do is, okay, here's the given question. I need to work backwards. I need to smush this together to one single trig function. So I have to figure out what formula they're using here. The information given to me is sine, cosine, plus cosine sine. Which formula says sine, cosine, plus cosine sine? What is it? Which one? Sine of u plus v. Agreed? Okay. So you just identified that this is the sine of u plus v. Well, guys, what's the u and what's the v? What's the u? 74. What's the v? 16. All right, we're smushing together. What is 74 plus 16? 90. What do you guys know about 90? Where is it? It's on the unit circle. When you have a problem like this and you smush back together, you'll always get something on the unit circle. So here's the first part of your answer. You wrote the original question here as a singular trig function. Perfect. Now you have to evaluate it. Okay, well, guys, what's the ordered pair at 90? 0, comma 1. Good. And sine is what value? The y. So what is the sine of 90? It's 1. That's it. You're just identifying, you're matching what they give you to the formulas, and then you're writing as one single trig function. You're smushing it together, and it'll always end up on the unit circle. Yeah.
What did you do like with the right side of it? Like how do you know which one is the U or which one's the V?
Which one's what?
The U and which one's the V?
The order that it's in. Just because the formula says u, right? Sine u, cosine v, and that's how it's written. So sine u, cosine v. Just matches with the formula.
For the website, are we submitting just a PDF or also just inputting it into?
I think you can input it on this one. Yeah. All right, let's look at this one. Which formula, before you guys start freaking out about anything, just look. Which formula goes cosine, cosine plus sine, sine? Which one is it? Okay, tell me which one. It's cosine of what? U minus v. Yes, I know there's a plus sign there, but which formula has a plus sign? It's the cosine minus, all right? So just pay attention to that. So now we're going to rewrite this as cosine what? Say it again. 280, good. Minus 40. Smush it together. What's 280 minus 40? 240. Is 240, guys, on the unit circle? Yeah, it sure is. That was the whole purpose of doing this. I'm smushing it back together. So now we're going to evaluate it. What is the ordered pair at 240? Negative 1/2 and negative root 3 over 2. Okay, perfect. And then cosine is what value? The x. So what is the cosine of 240 degrees? Negative 1/2. Now, I agree. If you did not have your unit circle and you did not have any of the formulas or identities, this is very hard. But if you have everything right in front of you, guys, you're literally matching. Look at the last one. Obviously, which trig functions are we dealing with in this one? Tangent. How do you know that? Because it says tan, 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 tan. Right? So look at the two tangent formulas. Which tangent formula matches the information given, where you're adding tangents on the top and subtracting on the bottom? Which one is it? U plus V. So it's tangent of U plus V. All right, well, the first one is U and the second one is V. So this is the same as the tangent of 190 plus 125, right? You guys agree? Okay, keep smushing it together. What is 190 plus 125? 315, good. All right, so there's the first part of your answer. You wrote the problem as a single trig function. Perfect. So now I look and I say, all right, well, what's the ordered pair at 315? Root 2 over 2, thank you, ma'am, and negative root 2 over 2. And then tangent is y over x, right? Well, this one's pretty simple. If I take my y value and I put it over the x, what do I get? Negative 1. Perfect. Once you identify which formula you're using, when you smush together, guys, your singular trig function, like tangent 315, cosine 240, it will end up on the unit circle, so then you can evaluate it. Does that make sense? You guys all right? Okay. Let's go to the last one, and then we're done. Now, this problem, initially I did this with A period at first, and they're like, what? Guys, this is really easy. After I was done, they were like, oh, not bad. So, work with me here. It says find the exact value of u plus v. Now, how is this question different? Do you guys see any angle measurements given? No. You guys aren't using the unit circle for this. There's nothing to look at on the unit circle. They gave you information about two triangles, triangle U and triangle V. They told you that the sine of U is 4/5. This is chapter 4, guys. I have no unit circle to look at. When they give me triangles and they tell me sine, cosine, or tangent, what letters are they giving me if they tell me sine is 4/5? They tell you what? Y and R. Perfect. I have X, a Y value, and an R value. What do you know about R? It's always positive. Okay, good. So they told me that my Y value was 4 and my R value is 5. Now I have to find the X value, but the second piece of information is telling me something. It's telling me that triangle U lies between 0 and pi/2. Okay, so triangle U is here. Why is that important information? The signs. Your X value and your Y value are both what? Positive, because it's in the first quadrant. Perfect. So how do you find X? X squared plus 4 squared equals 5 squared. So X squared plus 16 equals 25. X squared equals what? 9. What's X equal? 3. Okay, perfect. Now, I go one step further with this. You could go to the next triangle, but I go one step further. Just because it's so easy to make a little mistake. I like to say, okay, let me just write down the trig functions real quick. What is the sine of U? You guys don't have to do this, but you'll see why I do this in a second. What's the sine of U? Whatever what? 4/5, okay? What is cosine of U? 3/5, perfect. And then what's the tangent of U? 4/3. Okay, great. So let's go and figure out all the stuff they told us about triangle V. Okay, they told me triangle V is right here. What did they tell me with negative 12/13 in triangle V? The X over the R. So I know that my X value and my R value are something. What do I know X is? Why is X negative 12? Why do you know it's negative 12? R is always what? Positive. Right? Your R is always positive, so you know that negative sign goes with it. Now let's talk about the second piece of information they gave me. They told me that angle V lies between pi/2 and pi. So they told me angle V is right here. Why is that important? Why is that important? The X is negative, but they're also telling you that Y is what? Positive. Good. All right, so how do I find Y? I'm going to say negative 12 squared plus Y squared equals 13 squared. Negative 12 squared is 144 plus Y squared equals 169. Y squared equals what? 25. So Y equals 5. Okay, great. Now I'm going to go one step further like we just did. I'm going to write down my info for you. So what's this? What's the sine of V? What's the sine of V? 5/13. Good. What is the cosine of V? Negative 12/13. And then what is the tangent of V? 5/-12. Okay. So you guys are like, woo, okay, we're done. Guys, have we answered the question? What was the original question? I kind of forgot. Oh, you want the sine of U plus V. All right. We found all of that information to answer the question. We took all of chapter 4 and answered it right here. Now, you don't have to do these boxes like I did. I just think it's easier so when you're throwing stuff into the formula, you don't have to look back and forth and think, wait, what sign? Signs this over that. It's already there right in front of your face. Because what you're about to answer right now is the sine of u plus v. Right? Again, you're going to be given the formula, so it's right in front of you. So what is the formula for u plus v, for sine of u plus v? I'm going to write it out. You guys tell me, what is the formula? How does it go? For sine of u plus v. Sine u times cosine of v, what? Plus cosine u times the sine of v. Now, again, why I think it's important to put the info in the little boxes like I did. When I'm going in to fill my information in, I don't have to think, okay, when I look up here, sine is what over what? It's already written for you. It's just real easy. What is the sine of u? What did you guys write down? 4 over 5. What is the cosine of v? Negative 12 over 13. Plus, what is the cosine of u? 3 over 5. And then what is the sine of v? 5 over 13. Do you see why I think it's easier to write down a little bit of information? So you're not going sine of u. Okay, look at sine. That would be y over r, so it's 4 over 5. You don't even have to think. It's an easy way to make a mistake if you have to think extra. Honestly, when you guys are trying to go fast and you're moving through a test or something, I think it's easier to have all the information right in front of you. And now we just simplify. How do you multiply fractions? Numerator, right? Numerator times numerator. 4 times negative 12 is negative 48. 5 times 13 is? 5 times 13? 65. Plus, what's 3 times 5? 15 over 5 times 13. 65. Guys, what do you notice about the denominators? They're the same. They should be. Every single time you do this. If not, you should go, did something wrong, go back up here. Something wrong with my math. But you should have the same denominators when you get to this point. Now, can we simplify a little more? Yes. What's negative 48 plus 15? Negative 33 over 65. And if you can simplify more, go ahead. This one doesn't. But there's your answer. So we had to do everything from chapter 4 to set us up to be able to plug in everything for chapter 5. Do you guys see that? Not incredibly difficult. A little tedious, yes. Takes a little bit of time, but nothing that you guys can't handle. Questions? All right. Okay, we're done with chapter 5. Yay.